Hi everybody. Okay, so I want to just do a quick recap on how you do radioactive and absolute dating and half-lives. So on my screen right now, you see that I have this particular box, okay? So imagine that the other lines over here aren't here, but there's just one big box, okay? Remember, when we talk about radioactive decay means that over time, substances begin to break down. Okay, they don't exist in their original form anymore, and they disintegrate or break down into another form. And every specific amount of years, half of the original product that was there is gone. Okay, so if we take a look at this particular square, imagine we started off with one big square. If we went through our first half-life, that would mean we would cut the box in half. So we would have one half over here, and the other half over here would no longer be any good, so this half wouldn't exist anymore. So that would be one half-life. And then, so I'm going to put a 1 down here for a 1 half-life so far. And then this half, now, I wish I could cover up the screen somehow over here, but I really have yet to figure out or master that yet. So we have a half-life over here, so we'll do a 1 half-life. We have half of the original substance over here. Well, then we cut it in half again. So now we went through a second half-life. So now we're not focusing on here anymore. Now we're focusing just on this particular part up here. Now we take this and say this goes through another half-life. Well, we would cut that in half. So that would be our third half-life. And this would be gone. This is gone already, and this is gone already. And which means we're just left with this square over here. Now, if this square goes through a half-life, we cut it off right here. That'd be 4 half-lives. Now we don't worry about this little rectangle right here. So now all we're focusing on is this little square over here. Now, if this goes through a half-life, we cut that in half. So that'd be our 5th half-life we will have done. And remember, then we get rid of this little square over here. This side disintegrated, and all we're left with is right here, this one little square. Well, we're going to go through another half-life, cut that in half. And that would mean then that one of those would be gone, and that means altogether we were left with 6 half-lives. So that means that there were 6 half-lives in this picture, meaning that over a set period of time, this original gigantic square was broken down 6 times. It was cut in half over a set period of time. All right, so how does that work out for us in earth science? Well, if a sample contains 50 grams of carbon-14 and 50 grams of nitrogen-14, how many half-lives has it undergone? Okay, well, you may be saying, well, what does carbon-14 and nitrogen-14 have in common? Well, remember from the Earth Science reference table, I showed this to you in the presentation, so if you haven't seen that, please go back to my video. I believe I put it up on Wednesday. Rewatch that, no, not Wednesday, it was Tuesday. Rewatch that video, I mentioned this towards the end. So this is the original radioactive substance, and you see carbon breaks down into nitrogen-14. And that takes 5.7 times 10 to the third, or 5,700 years to happen, to lose half of the original carbon you had, to turn half of it into nitrogen. So let's go back to our question for a second. If we notice, it's a sample contains 50 grams of carbon and 50 grams of nitrogen. Well, if you contain 50 grams of nitrogen and 50 grams of nitrogen-14, then that means you will have undergone how many half-lives? Well, that means we originally started off with how much total substance? I mean, we originally started off with 100 grams, right? Because we don't lose things, they just turn into a different form. So that means we went from 100 grams, that eventually became 50 grams. Okay? So how many half-lives is that? That meant we cut it in half 1 time. So we went through 1 half-life. Alright, that means we underwent 1 half-life. Okay? Because we went from, we had half here and half here. Alright, so let's try a different one. That was a pretty easy one. This next one might be a little bit more challenging for us. So if a sample contains 25 grams of carbon-14 and 75 grams of nitrogen-14, how many half-lives has it undergone? Well, let's look at how much of the total amount of samples do we have altogether. Well, 25 carbon 14 and 75 nitrogen 14. So again, that gives us a total of 100 grams of a substance. Now, we want to disintegrate this down to where we only have 25 grams of carbon 14 left. Okay? So this means we started with 100 grams of C14. Okay? So if we have that 100 grams of C14, then we want to get that to 25 grams of carbon 14. Basically what we have to do, and this is really easy, we take 100, and if we break that down in half one time, so this arrow here is going to represent, every time I put an arrow here, this is going to represent a half-life. Okay, so I had 100 grams. Well, what would half of 100 grams be after one half-life? Well, that would be 50 grams. Does that get us to 25 grams of carbon 14? No way, no how. So now what we do is we do another half-life. Half of 50 is 25 grams. Now we just count up the arrows we had. We had 1, and we had 2. So that means how many half-lives has this undergone? This has done 2 half-lives. Or half-lives. Once I learn how to spell. Okay? So that has undergone all of the different half-lives. Okay? So remember, how did I know I started off with 100? Because there's 75 here and 25 here, add them all together, that gives me carbon 14. And how do I know I started with carbon 14 and not nitrogen 14? Remember, in order to get the nitrogen 14, you have to start off with carbon 14. And what's kind of neat is to think about is, eventually, even this 25 grams of carbon 14 will eventually become nitrogen 14. Okay, so let's go to the next question here. So if a sample contains 25 grams of carbon 14, oh, did I do the same? My fault. I'm going to give you guys the same question. I somehow repeated myself. So if we look here, how old is a bone in which carbon 14 has undergone 3 half-lives? Okay, well we know 1 half-life equals how many years? Remember, if you forget, you can go back to the reference table, right, which is right here, or you can go back to my presentation. So remember, 5.7 times 10 to the third, that's just another way of saying 5,700. That means 1 half-life equals 5,700 years. And all I want to do is I want to take that number and just multiply it by the number of half-lives that I'm going to undergo. So 1 half-life equals 5,700. So if I say 5,700 times 3 years, that comes out to 17,100 years. That means in order to have gotten 3 half-lives, it is going to take 17,100 years. This is why we use carbon 14 in the organic substances, because organic substances are only going to be able to maintain carbon 14 for a short amount of time. This is very, very short amount of time. Okay, so what percent of carbon is left after 25 half-lives? Now, this question is a little interesting only because we just kind of go like this. If we start off with 100%, okay, if we start off with 100%, and we do 1 half-life, remember I told you every time I draw an arrow, that's going to represent a half-life. How much of that original substance is left? If you think back to what I did up here, it'll kind of help you out. So that would be 50%. Now if I do another half-life, what's half of 50%? 25%. Do another half-life, how much of that is left? Well, that'd be 12.5%. Undergo another half-life. How many half-lives have I done? 1, 2, 3. Now we're going to do another one, and that's going to be 6.25%. And then I have to do one more half-life, so I got to get to 5 half-lives. So I got to go 1, 2, 3, 4, 5. So then all I have to do is just divide that in half one more time, and I get 3.125%. So what percent of carbon is left after that? 3.125% carbon-14 is left after 5 half-lives. Okay? Okay. So what happens to the amount of nitrogen-14 as carbon-14 decays? Well, we know, again, go back to our reference table, as the amount of carbon disintegrates, what has to happen to the amount of nitrogen? Well, as that happens is the amount of nitrogen-14 will double each time carbon-14 decays. Because as carbon-14 decays and breaks down, what happens is the reverse happens, the amount of nitrogen-14. Nitrogen-14 is going to increase as carbon breaks down, so we kind of look at it from that perspective. Alright, so if a 20-gram sample of carbon-14 has a half-life of 5,700 years, what would be the half-life of a 40-gram sample? So if we kind of think about this particular one, if a 20 grams of carbon-14 has a half-life of 5,700 years, what would be the half-life of a 40-gram sample? Now, if you think back to my presentation, I told you that nothing ever changes. Okay? Nothing ever changes a half-life. Half-lives are always going to be the same for this substance, regardless of how much you have, or regardless of how little you have, or regardless of the environmental factors. It's always going to be the same. The half-life for carbon-14 will always be 5,700 years. The amount of carbon-14 does not change how long the half-life has to occur. Okay? So even in that moment in time, right, it does not change the fact that whether you have a 40-gram substance, whether you have a 0.4 gram substance, the amount of time will always take 5,700 years. The amount of time never changes. Okay? Alright, so if you go to the Google Forms, you'll see that I have a Google Form set up for you. There's 2 questions that you have to answer, just 2, not that hard. And that's all you have to accomplish for today. Alright? If you have any questions, please put them down in the comments. Let me know what's going on, and I will respond back to you as best I can. If I don't talk to you at any point, I'm going to assume then you're feeling pretty solid with this. Okay? Take care, stay healthy, stay safe, and I will talk to you all soon.